moment you have a horrific situation at Blackwall Tunnel where typically on any day during the peak periods there's a 20-minute queue.
Notorious for its traffic congestion, London is undertaking a massive project, the Silvertown Tunnel. This $2.8 billion endeavor promises to alleviate the strain on the existing Blackwall Tunnel by creating a modern underground passage under the River Thames. However, the project has become a focal point of debate, raising concerns about potential drawbacks and anticipated benefits. In today's video, we will be looking at the $2.8 billion tunnel aimed at dividing London and how it is tailored towards decongesting traffic in the region. Stay tuned to the end, as it promises to be a very interesting and enlightening experience. Without further ado, let's begin. London, like many major cities, struggles with severe traffic congestion. Imagine battling a notorious rush hour. Thousands of cars crawl across the River Thames, funneling through a single narrow tunnel, the Blackwall. This ultimately leads to traffic congestion, which gradually gets worse as it's the only way to get across the river. The River Thames, while beautiful, acts as a significant north-south divider. What was the problem with the Blackwall? These existing river crossings haven't kept pace with the city's booming population. Being designed in the last few decades, it simply can't handle the current traffic volume. This problem ultimately results in delays that turn a 15-minute story into an hour-long journey. You would think the traffic congestion is where it ends, but that is not the worst part. With all those idling vehicles spewing fumes, it's not exactly a recipe for clean air, is it? This constant traffic congestion is a major contributor to London's air pollution woes. With all these problems, a need for a solution was born, which led to London constructing its first new east of the river tunnel in over 30 years, the mighty Silvertown.
City Hall insisted today there was no need for schools to close because the Mayor is investing hundreds of millions of pounds improving air quality.
The project offers an additional route beneath the river, whisking vehicles away from the congested surface streets. Reduced traffic flow could mean shorter travel times and a sigh of relief for frustrated drivers. With fewer cars stuck in traffic jams, the tunnel has the potential to combat air pollution and contribute to a cleaner London. Not everyone has the luxury of relying solely on public transport. The tunnel gives drivers more flexibility, especially in East London, where crossing options are limited. The Silvertown Tunnel Plan. It is planned to open in 2025, will stretch 1.4 kilometers, connecting Silvertown in the north to the Greenwich Peninsula in the south. This new passage aims to become a crucial artery for traffic flow, particularly for heavy goods vehicles and buses. Propagators of the Silvertown hail it as a solution to London's traffic woes. By diverting traffic away from the congested Blackwall Tunnel, the new route is expected to significantly reduce travel times by at least 20 minutes and enhance overall traffic flow in the city, which could lead to economic benefits, potentially attracting businesses and fostering development in the surrounding areas. But while the plan seems reasonable, do they have the means to achieve this monumental task? The project isn't just about the destination. This journey beneath London's bustling streets is a masterpiece, made through a mega drill, exempting it from other drills. The machine would play a crucial role on whether the project could continue smoothly or not.
Its purpose is to stop large volumes of sewage being discharged into the river at Abbey Mills pumping station, 7 kilometres from here.
The star of this subterranean show is the aptly named Tunnel Boring Machine, TBM Jill. This mind-blowing 82M 1,800-ton machine is the first of its kind, which would explain why this project's expenses skyrocketed into billions of US dollars. The cost of customized construction and maintenance is not a joke. Jill is much more than just a giant drill. At the forefront lies the ever-churning cutting head. This 12.19-meter vast wonder, adorned with tungsten carbide picks, acts as Jill's powerful jaws, relentlessly grinding through rock, clay, and whatever else lies in its path. Freshly excavated material needs a way out. A giant conveyor belt system within the machine continuously transports the debris rearwards. For stability and propulsion, Dorothy relies on powerful grippers. These massive mechanical claws clamp onto the tunnel walls, providing the necessary traction to push the machine forward as it excavates. As it burrows deeper, the tunnel needs a lining for stability. The need for stability is where the segment erector steps in. This ingenious compartment houses precast concrete segments, meticulously feeding them into place to form the tunnel's solid and secure walls. The construction process was smooth until they encountered a problem. What could that have been? While the Silvertown project configuration might seem straightforward, the construction process presents a significant challenge affecting the efficient excavation of both tunnels. Traditionally, constructing twin tunnels like this involves deploying two tunnel boring machines, TBMs. Each TBM would carve its path, ensuring a faster completion time. However, in the case of the Silvertown, space constraints pose a significant obstacle. Here's where the challenge arises from. The space near the riverbanks is insufficient to accommodate the launch and retrieval of two TBMs. This necessitates a single boring machine tackling the excavation of both tunnels. Also, dismantling and reassembling the machine is a highly time-consuming process that significantly extends the project timeline, translating to additional costs and delays. Maneuvering such a massive machine through the existing infrastructure and reassembling it precisely at the new starting point presents substantial logistical challenges. Faced with this spatial limitation, the project engineers devised a groundbreaking solution: the 180-degree TBM U-turn. While the core functions are impressive, Jill possesses a unique talent: the mid-tunnel U-turn. A single boring machine will carve both tunnels. To achieve this, Dorothy must perform a meticulously planned 180-degree turn within the tunnel's confined space. Extensive studies of the ground conditions ensure the chosen route for the U-turn is stable and can withstand the immense pressure exerted by the TBM during the maneuver. Engineers meticulously design the tunnel lining to ensure it can handle the stresses associated with the turn. This intricate maneuver relies on a symphony of specialized equipment and meticulous planning. Engineers devised an ingenious solution: the creation of a significant reversal chamber. This space provided the crucial turning radius required for the TBM to execute its 180-degree maneuver. Here's how they pulled it off. Specially designed devices, each consisting of a hydraulic cylinder and an inflatable cushion, played a pivotal role. Compressed nitrogen was pumped into the base of each skate, inflating the cushion and creating a pillow of air between the machine and the chamber floor. With the machine essentially floating on this air cushion, the risk of friction against the tunnel walls was minimized. Once lifted and positioned on the nitrogen skates, the TBM was meticulously rotated in 2 complete turns. This intricate maneuver demanded precise planning and flawless execution to ensure the machine's alignment for the return excavation. Structural engineers ensured the reversal chamber could withstand the immense weight of the Jill and the forces exerted during the rotation. Jill may be the star, but a supporting cast plays a crucial role. A network of conveyor belts moves from the tunnel face, transporting the excavated material, called muck, towards waiting barges on the river. As the machine delves deeper, sophisticated water management systems are in place to prevent water ingress from the Thames. Maintaining fresh air within the tunnel is crucial. A complex ventilation system ensures the crew a safe and healthy working environment. The excavation process is akin to a well-orchestrated symphony. Many sensors constantly monitor various parameters, including real-time data on soil composition and pressure, ensuring that they are within safe parameters. Vital statistics like cutting head rotation and thrust force are monitored to optimize efficiency and prevent equipment failure. Stringent monitoring systems track water quality and dust levels to minimize environmental disruption.
No, electric vehicles are great, but they shouldn't be a one choice of transport inflicted.
Another challenge is being faced in the construction of this tunnel. Let's go through the details. The Silvertown Tunnel project, while boasting impressive feats of engineering, faced multiple share of challenges. Imagine constructing a massive tunnel amidst a complex web of existing infrastructure. You are bound to encounter difficulties. The Docklands Light Railway, DLR, bisects the construction site, necessitating meticulous planning to ensure minimal disruption to this vital public transport service. A busy road runs parallel to the construction zone, requiring careful traffic management strategies to maintain the flow of vehicles and pedestrian safety. Building a tunnel beneath a major river like the Thames presents inherent challenges. Stringent measures are required to safeguard water quality and prevent environmental damage. What about the impact of the project's footprint on the immediate environment? Construction activities lead to noise pollution, dust emissions, and disruptions to residents' daily lives. The presence of the cable car and the proximity to London City Airport's flight path necessitated careful coordination to to ensure the safety of both construction crews and air traffic. Controversy surrounding the project. The Silvertown Tunnel, envisioned as a solution to London's traffic woes, has surprisingly become a project shrouded in controversy. While the prospect of alleviated congestion holds undeniable appeal, the project has drawn criticism from various groups. Environmental activists voice their opposition rooted in the potential detrimental impact on London's green goals. Critics argue that the new tunnel will simply induce more vehicles on the road, leading to a rise in air pollution. This problem directly contradicts London's ambitious target of achieving net zero emissions by 2030. In addition, many opponents highlighted the project's shortcomings in promoting sustainable transportation. The tunnel's design solely caters to vehicles, overlooking the growing demand for safer and more accessible infrastructure for pedestrians and cyclists. This approach starkly contrasts the city's commitment to promoting environmentally friendly modes of transportation, like cycling and walking. In its current form, the project appears to prioritize car traffic over promoting a shift towards a more sustainable transportation ecosystem, which raises concerns about its alignment with London's long-term environmental goals. While it's clear about the discomfort the project brought, we seem to be neglecting its impact on public finances. Why did the public express strong disapproval, even though it was something that would make their lives easier? Drivers will face an annual road tax, a congestion charge in specific zones, and a fee to enter the ultra-low emission zone, ULEZ, with older vehicles. Adding tolls to the Silvertown Tunnel is seen as an unnecessary financial strain on motorists.
Absolutely right, and everyone knows, I don't know if people right across the country know how pleasurable it is to go through the Blackwall tunnel.
For many Londoners, the additional cost of using the tunnel further squeezes household budgets. This economic factor adds another layer of opposition to the project. While the project's proponents highlight its potential to improve traffic flow and offer an alternative route, addressing the opposition's concerns is crucial for its long-term success. What do you think about London's $2.8 billion project? Do you think the opposition stances are valid? Or do you think the good outweighs the bad? Feel free to let us know your thoughts in the comment section below, and don't forget to like and subscribe to our channel so you won't miss out on future updates.